All right, you ready? Okay, so today's lesson is note 7.3, similar triangles. This is very similar to what you all learned in middle school, where you would have two triangles that were the same shape but not the same size, and you may have had like a missing side. One of the sides was missing and they asked you to find it. And what you would do is you would coordinate the same sides and you would make a proportion, and then you would cross multiply and solve it. Same thing, except for we're going to learn some shortcuts. If you don't understand the shortcuts, it's okay to go back to what you learned in middle school to find the missing sides. But if you understand the shortcuts, then go ahead and use them. They will also ask you a geometric mean problem on the EOC, so it's best that you try to understand how to set it up. We're going to use color today to make sure that you can see the pattern. All right, first one. The theorem is if the altitude is drawn to the hypotenuse of a right triangle, then the two triangles formed are similar to the original triangles and to each other. Now, before I start this, we need to talk about the word altitude. What does the word altitude mean? Good. Okay, so we use the word altitude, and it is the height of the triangle. How many altitudes does a triangle have? Most people think one, but it's not. It's what? Three. Okay. Okay, so 3. Now, where are they? If you thought it was 1, where are they? I'm going to flip my paper over to this side so you can see them. Okay. Let's take that right triangle that we saw over there, ABC. And this is A, this is B, this is C. This, as I have it drawn here, this is the right angle. That means that this is the base, and this would be the height. So this was considered the altitude this time. If I flip it over this way, now this is the base, so what would the altitude be this time? Good, BC. But when I have AC as the base, I have to draw the altitude from the vertex straight down to the base, and it's perpendicular. Does it cut the base in half? It can, but it doesn't necessarily cut the base in half. But it will always be perpendicular to the base. Okay, let's flip it back over to the other side and continue. All right, so as our theorem stated, we have 3 triangles now. We have our original, which I'm going to color in green. This is my large triangle. And then my medium triangle, which I'm going to choose a different color. I'm choosing yellow. And then my small one, which I'm going to choose pink. Okay, what this is saying is that they are all similar. Large, which is green, is going to be similar to the medium. The large one is going to be similar to the small one. Oops, I colored that wrong. Don't follow me, folks. I made a mistake. I chose the wrong color to highlight this in. That should be yellow. Okay. And then medium, which is yellow, to the small one. So every single one. Large is similar to medium, large is similar to small, medium is similar to small. All different combinations. Okay. So what you would do in middle school is you would take the large, the medium, and the small, and you would redraw them so that they were all facing the same direction. So you would just tilt them up. This would be the large one. This would be the medium, and this would be the small. And then you would relabel them. So here, this would be B, this would be the tall side, so that would be A, and this would be C. And then your medium, the yellow one, this right angle here is D. Then the large side is A, and then across here would be B. And that would be the hardest part, is just relabeling them. This one is sitting the right way, so that's B, D, and C. So there's your small, medium, and large. And then if you had numbers, you would put the numbers, measurements, you put them where they belong, and then you would set up proportions to find whatever side you were missing. Okay, here's one of the shortcuts I was telling you about. It's called the geometric mean theorem, and this is the one that's dealing with altitude. So what I'd like for you to do is highlight the word altitude. And it says if BD is drawn from the right angle excuse me, down to the hypotenuse of triangle ABC. So we're talking about this being the altitude. So in a right triangle, the altitude from the right angle to the hypotenuse divides the hypotenuse into two segments. Okay, so here the altitude is yellow. The hypotenuse of the large triangle is AC. So it's dividing that green segment into two separate pieces. A large piece and a smaller piece. And go ahead and make sure that you color these, because it's going to be important when we start to fill in the blanks. Okay, so what this says is when this happens, when it occurs, that we dump it over on the hypotenuse and we draw an altitude and cut that hypotenuse into two pieces, a small one and a big one, then there's a certain way that we can set up a proportion. We put the base of the small triangle, so look at the small one, base of small triangle over the altitude of the small triangle. And we're going to set that equal to the base of the medium triangle over the altitude of the medium triangle. Okay? Everybody focus in on the small triangle first. We're talking about this one here, BDC. What segment would be considered the base of the small triangle? Okay, so that's in red, so go ahead and take that first box and just kind of color it in red before you fill it in. And that's going to fill it in with DC. So whatever measurement that is, that's where you would put it. You would put it on the top left-hand side of the proportion. Okay, now, focusing on the small triangle, what is the altitude of the small triangle? Good. And that one's in yellow, so I'm going to color this box in yellow. And that's going to be BD. And now we focus on the medium triangle. Now remember, the medium triangle is this one here, and it's kind of tumped over on its side. We've got A, D, B. So when we talk about the base of the medium, we're talking about the smaller side, because remember, the base was the smaller side. So here, the base is going to be yellow. going to be BD. And then the altitude. What would be the altitude of the medium? AD. Good. So I'm going to highlight this one, blue. Okay. So the length of the altitude is the geometric mean of the lengths of the two segments. Okay, so basically you have the two segments, and notice how the two segments are the extremes of the proportion. When you have a proportion, you're going to have a number over number on the left and a number over a number on the right. The very first number that you write down, which is this one, we call that an extreme. And the very last number that you write, which would be the blue one, that's also an extreme. So the red and the blue are extremes, and the two in the center are the means. That's what we call the means of a proportion. Those will always be the same color because they will be the same length. That's why it's called the geometric mean. They are the same. All right, so this is just a shortcut. So if you look at it, just cover this up and look at it again. You're going to write one of the sides. See how it cuts it into two pieces? You're going to put one of the pieces over the altitude equals the altitude over the other piece. And it really doesn't matter if you put the long piece or the short piece first, but it's always going to be piece over altitude equals altitude over piece. Piece, the red one, over the altitude equals the altitude over the piece. Got it? All right, let's move on. Okay, next page. Geometric mean, and then they put leg theorem. Now, when we have a right triangle, how many legs do we have? Two. Now, is always one of them going to be shorter than the other? No, because you could have what? They could be equal, and when they are, what do we call it? Isosceles. Good, isosceles. But we don't always have isosceles. Most of the time, you're going to have a short and a long side. So that's why you'll see down here, long leg, short leg. Okay? If both of them are the same, then it doesn't matter. You just have to do whatever you're doing once. You don't have to find the long leg or the short leg, because once you find it, it'll equal the other one. Okay. All right, so here, notice how this is exactly the same. It starts off the same, and then it has another piece down here. It says, in a right triangle, the blank from the blank. What did we draw? The altitude. The altitude from the blank blank, right angle here, from the right angle, to the, okay, we call that base the what? Hypotenuse. Divides the hypotenuse into two segments, just like before. Okay, to understand this one a little better, we need to move down here and fill this out before we fill this out up here, because it'll just help us understand what's going on. Whenever I have a difficult problem that requires me to set up a proportion, and I have pieces that are all mixed up and I can't figure out which one goes where, I use a strategy called tic-tac-toe, this tic-tac-toe box, in order to sort out the pieces. So this is just a strategy that you can use, and it doesn't have to be with triangles. It could be with a word problem as well. So you draw a tic-tac-toe box, and the top left corner will always be filled in. This line and this line are for your categories. Because we're looking for the long leg, we're going to use the large triangle, and both times we're going to use the large triangle, by the way, because it was the original. But we're going to use the large one and the medium one. When we're dealing with the short leg, we're going to use the large one and the small triangle. Okay, so hypotenuse, long leg, and down here will be hypotenuse, short leg. here, there's the large triangle and the medium. This is the large triangle and the small. So that's how you would set it up. So now let's go through and let's look at let's look at what is the, focus on the large triangle. What is the hypotenuse of the large triangle? CA. Good. Okay, because that was, I'm going to choose a color. I'm going to color that in. I'm choosing yellow. So CA is yellow. CA. And yes, you can write AC. It doesn't matter because it's the same. What is the long leg of the large triangle? Say it again. BC. Okay, good. I'm going to use green for that one. All right, so that's going to be BC. Okay, now let's focus in on the medium triangle. Remember, the medium triangle is over here. I need the hypotenuse of the medium triangle. What color is it? Good, it is. It's already colored green. And you should already see the geometric mean show up, because remember, the first one and the last one that you write down as the proportion are going to be different colors, and then these two in the middle are the mean, so those will always be the same color. All right, and then the long leg of the medium triangle. What's the long leg of the medium triangle? CD. So I need a different color for that one. So I'm going to choose red. CD. Okay, so see how the geometric mean shows up with these two being the same color? Now look how this works. Look at this drawing. Focus in on this drawing. It's going to be the hypotenuse of the large triangle over the long leg equals the long leg over the part of the hypotenuse that's longer, because we're dealing with long legs, so it's going to be the longer piece, or the piece that's attached, adjacent to that side, not this one over here that's far away from it. Okay? Let's do this one. So hypotenuse of the large, same thing. I'm going to use the same colors. So again, that's CA. And then, let's see. I'm going to need a different color because I need the hypotenuse of the small triangle. What would be the hypotenuse of the small? Good. BA. Okay, now without even looking at the categories, what color is that one going to be? So for me, it's going to be blue, because these two are always going to be the same color. So for me, it's going to be blue. So I know that's going to be BA. Now check it. Is the short leg of the large triangle BA? Okay, so it works. Now, what is the short leg of the small triangle? That goes here. So we're going to need a different color for that one. So I'm going to choose pink for that one. That's going to be AD. And again, if you look at it, it's going to be the hypotenuse over short leg equals short leg over short piece. That's how you set it up. So that's the pattern. So let's go back up here. Can you still see it? Got it? Yeah. Okay. Let's go back up here and fill this out. Okay, now I accidentally switched these, so if you'll switch them for me, this should be C over here, and this should be A. So it matches the ones below. Okay, so what that tells me is that, remember I always start with the hypotenuse. The hypotenuse is what? All right, CA, CA over long leg. What's the long leg? Long leg of the large triangle. Okay, BC. So what goes up here? BC. And then the longer piece, the one that's attached to, adjacent to BC. What is that one? Good, CD. All right, the next one, start with the hypotenuse. So what's the hypotenuse? CA or AC, doesn't matter. Over the short leg, what's the short leg? BA. Equals short leg? BA over. Okay, the length of each leg is the geometric mean of the lengths of the hypotenuse and the segment of the hypotenuse that is adjacent to the leg. Okay, we're done with the lesson part. In part 2 of the video, you're going to have 2 videos. This is part 1. Part 2 of the videos are going to cover the examples.